Okay, so in the previous video, we went through going and tracking this motion of the ball throughout the duration of the throw and identifying the section of the video that we wanted to export to actually do our analysis. Just to do a quick review, we've already exported this to a spreadsheet in the Microsoft Excel format, and we put that into our folder of, of, of BEaM exports on my hard drive here. So now what I'm going to do is I'm going to open Excel. This is the folder where I've exported the data from. So you can see we have desktop. This is my service folder for the previous academic year, the BEaM Camp and Excel Motion. So that's where I saved it to. And you see this is the Excel short throw, which we had in the previous videos. And this is the long throw that we just exported. And you can see that has this data on it. So this is the raw data that we get from this. The first thing that I'm going to do is actually save this in a different format because this XLM data is not going to save all the different formulas and stuff like that that I want to put in for this analysis. So I'm going to File, Save As. I'm going to change this from XLM to Excel Workbook, the XLSX format, then hit Save. The other advantage to doing this is now anything I do to modify this, I still have the original raw data that I can use to go back to if I break something or mess something up. I'm going to insert an extra row here to get some additional data into this spreadsheet without having to kind of cross over into these bottom ones. I'm going to put the length of the paddle in meters. Again, this data here is all in pixels, so I want to convert that into meters before I do any of my calculations. And to do that, I have already measured my paddle. So I measured out to just under 54 inches, which is about 1.3 meters. So I'm going to put that as 1.3. Then I also want to know the length of the paddle in pixels. And that's how I'm going to do the conversion. If I know the length of an object in both pixels and in meters, I can convert the pixels into meters using that. So what I'm going to do is I'm going to go back into the Kinovia software. I'm going to find the frame that I'm using for my paddle measurement. So here we go. Here's the paddle. And you can see that it's pretty constant. I'm just hanging it between my fingers here. And so I'm going to use the coordinate system origin tool. We did actually set the origin here to measure this paddle. I'm going to make this a little bit bigger so I can do it a little bit easier. And then what I'm going to do is I'm going to put the origin at the bottom of the paddle. And then I'm going to look for the line so the line crosses the top of the paddle. And it looks like my orientation here is not quite straight. There's a little bit of a lean to this video, but I'm basically just going to neglect that and call it close enough. And we can see here that the x component of this is negative 196. Right? And again, you could say, okay, well, is it that one or that one or that one? But again, we're just trying to get close. So negative 196 seems fine. So I'm just going to take that and type in negative 196 into here. And again, I'll check that to make sure I have that right, or that I have the right number. Good, 196. And so that's going to be the length of my paddle. So I'm going to use these two values, the length of the paddle that I measured using a measuring tape, and then the length of the paddle that I have measured inside the camera frame. And I'm going to use that to convert this coordinates into position. So I'm going to put a position value here. Say position in meters. And I'm going to put that in X and Y. And you may also want to note here that X is going to be height. And Y is kind of, I don't know, width. Or you can say vertical and horizontal or whatever you want to consider it, right? With some kind of annotation there just so you can keep track of which is which. And I'm going to use the same scaling factor for both of these. Now, I don't know that my camera isn't actually scaling this and becoming less accurate in terms of frames of these. If you really wanted to know how accurate your camera was, you would have a grid of constantly spaced points all throughout the field of view of the camera, and you could calibrate based off of that. And if you were doing this for a professional context, you would do that, or buy a camera where someone had already done that, and we could kind of confirm that the distances inside the pixel view were the same throughout the whole thing. And this one, we're just going to assume that the camera is reasonably square and that the x and the y distances are comparable. So we have it in pixels. So this is our x coordinate in pixels. To convert that into meters, we multiply times the length in meters and divide by the length of the paddle. Now, I always want to use the same values here, but I'm going to change these ones. So what I'm going to do is I'm going to fix the reference for F1 and F2 inside Excel so that way they're not varying as I copy and paste this. The easiest way to do this is to press F4, and that puts the dollar signs in front of the F and the 1. That dollar sign means that if I copy and paste this cell, it'll update the relative position of A7, but it'll keep the absolute position for F1. And I'll show you guys how that works here in a second. So if I take this and I move it down, you can see that the F1, F2 stay the same, but the A12 changed as it got pulled down. If I go the other way too, you can see that that moves around, but those ones stay the same. If I didn't have that dollar sign on there, I'll just cycle through these real quick to show you what happens to those. If I didn't have that dollar sign, you see this wouldn't work because now it doesn't keep that position in the correct spot. So it doesn't really work. So that's a convenient tool in Excel for us to use absolute or relative referencing. So I'm going to drag this all the way down so I get the values for the entire series. And then drag it across. And now I've got my x coordinate in x and y in meters for the duration of the throw. And I can center align these just to make it look a little bit cleaner. And I probably want to use a certain number of decimals, so I'm going to go into format cells. I'm going to make this into 2 decimal places. And now I've got a nice series here. Now if I want to plot this out, I probably want to plot this versus time. Now this time series is the timestamp as it comes in, and this is actually not being formatted in a method that Excel likes. But I know that my time is actually being calculated as in 30 hertz or 30 frames per second. So I can make a frames value. And I'm going to start that at 0 just because I want time to start at 0. And I'm going to say time in seconds. I'm going to say equals to the frame divided by 30. And I'll make sure my frame increments as I go down. Looks like that's working good. Pull that down so that it's filling those in. And then again, I'm just going to pull all this down at the same time, all the way down to my bottom. And you probably want to make sure that your time here matches the time here. If there's some kind of shift, make sure that you're actually calculating this right and that you're not having any kind of weird offsets. It looks like mine is getting slightly off. Oh, wait, 0.613. I may have had some dropped frames. So you can see here there's a drop frame at frame 20. So I don't actually have a 23. So I'm just going to fudge that up by making that 8, 9. I don't know if I probably have a couple more too. And that's probably an artifact of my camera system. 50. Yeah, it looks like I have a couple more too. Easier way of doing this may be to just try and convert this value across. I'm actually going to pause the video and then return after I figured out the fastest way to fix this. So actually the easiest way I found to fix this was to go back into the Keynote VDS software and change the format of the timestamp from the hours, minutes, seconds, hundreds of seconds format into just a milliseconds format. It was actually quite a bit more convenient. So you go back into the options setting here, there's a time marker format, and you can do classic frames, total milliseconds, or classic plus frame numbers. Probably the total milliseconds is probably the most convenient one. I'm not sure why this skips around so much in this video, but it's probably just a function of the compression format that the video codec is using. So I would suggest you use the total milliseconds point when you before you export. And I guess I just re-exported it into Excel. Then I actually copied over the edits that I had done already in Excel into a new Excel spreadsheet. And I'm just going to save that as a new XLS workbook. Now that I have that, I'm actually going to delete this frames count. And I'm just going to set this equal to the time divided by 1,000. That should give me the time in seconds. Oh, accidentally edited out the C. That's okay. C7 divided by 1,000. There we go. Now I can pull this all the way down. We should have our time in seconds. All right, now that we've got that fixed, we can actually start calculating the different values we want to do, or the different things we want to calculate for this. So if I want to calculate the velocity and acceleration, just like I did last time, I'm going to use a forward and a backwards difference algorithm. To save time, I'm just going to copy these headers over and then change this to velocity in meters per second and acceleration in meters per second squared. And then for my forward difference, I'm going to use the next value, subtract the current value, and then I'm going to divide that by the next time, subtracting by the current time. Again, that next minus current, that's the forward difference part. Now I want to be able to use this for all of my x's and all my y's. I want the time to stay where it is, but I want the x and the y to copy over. So I'm going to use the same kind of trick before, but rather than locking both the cell and the row, I'm just going to lock the column, the D. And I'm just pressing F4 3 times to go from an absolute reference to a locked row to a locked column. Then once I've got that, I should be able to drag this down and across and get all the references that I want. And so you see that he stays in the right position. That also stays in the right position. Now I've got those, I'll drag it all the way down. Now I could actually keep this just like it is, and I could drag this over to my acceleration. And because of the positioning of that, that would keep the same thing. Except I don't really want to do that because I want to use the backwards difference instead of the forward difference. So the way I'm going to cheat that is I'm just going to cut out the text of the cell, go into the next one down, and then paste it back in. And now rather than going to the next value, it's the previous value. So it's the previous one instead of the next one, which is a nice little kind of cheat to make that a little bit quicker. Also, you may note that this one is actually calculating a little bit further down. The 0 at the end, that's probably an artifact of the system here. So I'm actually going to cut that out and just leave it just like that. So I'm a little more confidence in my data range. And I also don't like having all this stuff as a bunch of extra digits. So I'm going to format these so I only have 2 decimals on each of those values. Now I've got my position, my velocity, and my acceleration. So I'm going to save that before I go on any further.